Uranium is used for nuclear energy. This is because it is a heavy metal with a heavy nucleus, which means it can be used to create an abundant source of energy. Uranium is usually mined. If the uranium is near the surface, then the mining process is open pit or strip mining. This is when you remove surface oils and rocks to get to the ore below. This extraction process leaves a huge footprint as there are 500,000 tons of waste rock and 100,000 tons of mill tailings. Mill tailing is the radioactive material that is remained after the uranium is extracted. Uranium is able to be mined as it is barely radioactive in its natural form and is not radioactive unless in a powdered form. The contaminated area of the mines can contaminate water supplies. It makes sense to recycle uranium as this will reduce the mining, which then will reduce the waste rocks that comes from the mining. Uranium is traditionally used to create energy in a light water reactor. This is when fuel rods made of concentrated uranium creates heat. This heat is used to boil water, which then creates high-pressure steam to drive turbines to create energy. The rods can create energy because it transforms the uranium into different elements. Fission products, or waste products, start to build up. After 4 years, they replace the rods. About 4% is fission products, atomic fragments, 95% is uranium, and 1% is transuranic elements. Transuranic elements are elements which has an atomic number of higher than 92. The fission products cannot be recycled, so we would have to separate them from the rest of the rod. They are thoroughly mixed with reusable uranium. We can separate the waste from the reusable materials by pyroprocessing. It uses electrical currents and chemical reactions to separate the elements and material. The first step is to cut the rods into small pieces. Then you put them in molten salt. After, you run an electric current to separate the uranium and transuranic elements from the waste. You then put the newly recycled products into a fast spectrum reactor. After the recycled waste is used, instead of taking several of thousands of years to decay, it will only take around 500 years. Overall, recycling uranium will do the world good, but here are some factors. You could power the whole of America for thousands of years with the non-recycled uranium that we currently have. This is why we should recycle uranium. Australia has not yet begun nuclear enrichment. Only countries such as Japan, Russia, and America have reactors that are able to recycle uranium. The government of Australia says that legislative prohibitions on enrichment, fuel fabrication, reprocessing, and nuclear power plants would need to be removed before any of these activities can occur in Australia. Australia has not yet done this, as Senator Edwards says that the technology is not yet feasible to create low-cost energy. Socially, recycling uranium would be worse, as even though it is better for the environment, mining creates many jobs. There are more jobs for mining uranium than recycling uranium, as that takes a higher education. Economically, recycling the uranium is expensive. They are still improving the method, and the research is very costly. Although in the long run, it would save money, as once the technology is advanced enough and low cost, it will become cheaper than mining. Australia uses $12 billion every year for nuclear energy, with a total capital expenditure of $16 billion. Although environmentally, recycling uranium rods drastically decreases their radioactiveness. This improves people's health who would live around the reactors. Also, we would not have to mine uranium as much since we will be recycling them. And as stated earlier, mining uranium leaves a big footprint, as there are mill tailings and waste rocks. So, in conclusion, I think that recycling uranium will be a lot better for the world in the long run when it becomes low cost, as people will afford the energy, and it is better for the environment. So it is a win-win situation.